Hello students, in this chapter we are going to discuss some more points on pointers. So the first among them is pointer to a function. So you must remember that what is a pointer. We know that pointer is a variable which holds the address of an object. Here what is an object? Object is anything which is there in the memory. Okay, so an object can be an instance of a class. Object can be a variable of int data type. It can be variable of char data type. It can be variable of double data type. It can be an array. It can be a structure variable. So all these things are objects. Okay, so pointer is a variable which holds the address of an object. Okay, so now what is a function? We have discussed functions, so we know that a function provides a functionality. It is meant for doing a particular task. Okay, so it gives us a behavior. Okay, for example, there is a function to add two numbers. So what is the functionality of that function? The function is meant for adding two numbers. Okay, so in this chapter, we are discussing pointer to a function. Now, what is a pointer to a function? Pointer to a function is a pointer that stores the address of a function. Okay. So, for example, if you write a function int sum, int a, int b, then return a plus b. Okay. So, this is the code which you have written, and when you compile this program, this code is converted into machine readable code, okay, which is placed there in the memory. Okay, so whenever something is placed in the memory, it has got an address. So if a class instance has an address, if an integer variable has an address, so a function also has an address. Okay, so we can also have a pointer to store the address of a function, and that pointer is a pointer to a function. Okay, so now the question arises, how to create a pointer to a function. So the syntax for that is, so here we have three things. So first is int. This is the return type. Okay, then inside these parentheses we have star foo. Okay, so foo is the name of the function. You can use any other name, and here we have put an asterisk, which means this is a pointer to a function. Okay, so this indicates that this is not a function itself, rather it is a pointer to a function. So it means it will hold the address of a function. And here in the parentheses we indicate the parameters, and in this case there is only one parameter. Okay, so what does it mean? It means that here we are going to create a pointer to a function whose name is foo, and this pointer will point to a function which has an integer return type and which has one integer parameter. Okay, so it can hold the address of a function which has this prototype. Can it hold the address of a function which has this data type? Double f int. Can it hold its address? The answer is no. Okay, so here we are explicitly specifying what should be the return type and what should be the parameters for a function whose address can be stored in this function pointer. Okay, similarly, if I write double f and I do not give any parameters here, then also this pointer cannot point to this function. Okay, so the return type and the parameter list both should match with that of the declaration. Both these things of the function should match with that of this pointer to a function. Okay, only then we can point to this pointer to a function can point to the function. Okay, so let me first erase this. Now the question arises that what happens if you skip this parenthesis? You just write int star foo int, then what will happen? Then what will happen is this is the return type. Okay, and here these are the parameters, and foo is the name of the function or the pointer. Let us see. We are doubtful about this. We do not know whether this is the name of the function or the name of the pointer. In this case, this is pretty sure. We are pretty sure that this is the name of the pointer to the function because we have put a parenthesis here. But here we do not have put the parenthesis. Then what will happen? The compiler will check the precedence of this star with, and it will compare this precedence with that of these parentheses, and it finds that its precedence is lower and its precedence is higher. Okay, so it has got more precedence and it has got less precedence. Then what will happen? Compiler will associate this foo with this, and it will associate int star with this asterisk with this int. Then what is this now? It means this is the name of the function, not the pointer. Now it becomes the name of the function. Okay, and the return type is now not integer. Earlier, if you put a parenthesis, then it means the return type is integer. But now, let me go back. So, but now it means its return type is int star. It means this function foo is returning a pointer to an integer. Okay, so this is very important to always place the parenthesis here. Okay, so we put the parenthesis here so that the ambiguity is resolved. Okay, so we want to overwrite this precedence relationship, therefore we put the parenthesis. Okay, so this is the syntax for a pointer to a function. Okay, so now let us go to code blocks and write some code. So let us first create a function. Okay, so let us create a simple function void f1, and here let us print something in f1. Okay, ENDL, right? And in the main function, let us create the pointer to a function, pointer to this function. So return type is void. Then inside the parenthesis, we write asterisk and then name of the pointer. So let the name of the pointer be fp, and then we have another set of parentheses in which we specify the parameters, but this f1 function has got no parameters, so we can also leave it empty. So this is the pointer, and now how to assign the address of f1 to this pointer, fp is equal to address of f1. Okay, so let us write return 0 and let us run it. So this is not giving us any output. Why? Because here we did not call this f1. We neither called it directly, nor we called it using the function pointer. So we know how to call this function directly. We will write f1 and semicolon. Okay, so this is the direct call. And how to call this using function pointer? Name of the function pointer, then parenthesis and semicolon. Okay, so now we are calling it two times. That is why it is giving us in f1 two times. Okay, so this is a simple pointer to a function. Okay, so now let us complicate it more. Instead of word, let us use int. Okay, before that, one point I want to say that ampersand is not compulsory. You can skip ampersand here. Still, FP will hold the address of F1. It is also fine. So still, it is working fine. So you can write the ampersand or you can skip the ampersand. Okay. Okay. So now instead of word, let us have int. Okay, and here let us put a return statement, return 10 suppose. Okay, so now what do we need to change here? Instead of word, it should be int. Only then we can assign fp to f1. Okay, so let me show what kind of error we get if we do not change its return type to match with that of f1. Okay, so now f1 return type is int while fp return type is word. Let us run it. So it is giving error, invalid conversion from int star to word star. Okay, so we need to change it. Let us make it int. Okay, so let us again run it. Now it is running fine, but this function is also returning a value. So let me comment out the direct call because we are concerned about the pointer to a function. Okay, so here it is returning something. So let us use the cout statement. So now we will be able to get that value. So it is printing 10. Okay, now let us change it and complicate the things little bit more. So now instead of having 0 parameter, now it is having 1 parameter, that is int I. Okay, and now instead of returning 10, let it return I multiplied by 10. Okay, and here in the main function, what we need to change? We need to change the definition of this pointer function, pointer to a function. Okay, so in the parameters list, we need to include an integer. Okay, and then we assign the address of f1 to fp, and now cout fp. Will it work? Let us try. No, it is not working. Why? Because it is saying too few arguments to the function. It is the function is expecting one argument and we are passing none. So instead, let us pass one argument. Okay, so we are passing one argument. Now, what should it print? It should print 100. Okay, because we are passing 10 here and I will receive the value 10. I into 10, that is 10 into 10, 100 it is returning. Okay, so this is a pointer to a function. And now let us take another parameter, int j, and then return I multiplied by j. Okay, and here what we need to change? We now need two parameters. Okay, and this is fine, and here we need to pass two parameters. Okay, now it will give us the multiplication of 10 and 20, that is 200. Okay, now let us create another function f2, int f2, and here let us take only one parameter, let us say x, int x, and let us print in f2, and let us return x multiplied by x. So it is giving us the square of the value. Okay, so now can we use the same fp to store the address of f2? Let us check it. No, because there is invalid conversion from int star int to int star int int. So this is the function which we have, this is the function which we have created, and this is the uh, prototype of the pointer which we have used. Okay, so both are not matching with each other, therefore this is not permissible. Okay, so we need to create another fp. Okay, but okay, so let us change it to int x and int y. Okay, now we have two parameters and return x plus y. Okay, so now this function f2 has the same prototype as f1. The return type is int, and there are two parameters, both of them are of int type. Okay, so now will this work? uh, do not let us write remove it from here and write it here. Okay, so we were saying fp is equal to f2. Now is it permissible? Yes, it is permissible, because now the prototype of the pointer is matching with that of the function. Okay, so we have used the same pointer to point to different functions at different times. Okay, so let us also call this f2 through this fp, and again pass the same values 10 and 20. It should give us the sum of these two values. So it is giving us 30. 10 plus 20 is 30. Okay, so the same fp is used to call different functions at different times. So I think this might remind you of the concept of virtual functions which we discussed in the chapter concerned with polymorphism. Okay, so there was only one pointer, but depending upon the binding at runtime, the pointer was bound to different functions. Okay, so this is also a similar concept. Okay, another thing to note in this program is that if I write fp is equal to f2 followed by parentheses, then what will happen? Now it is giving us an error. Error is too few arguments to function int f2 int int. Okay, so it is saying too few arguments. Let us pass some arguments here. Uh, let us pass 1 and 2. Okay, so now run it. Now again it is giving us an error. It is saying that it is invalid conversion from int to int star int int. Okay, so this is not permissible. We are trying to, it is saying that we are trying to convert from an integer to an int star int int. Why is it saying so? Is this, are we assigning the address here? Think for a moment. This is not the assignment of address of f2 to fp. Rather, it is a function call. Okay, so address is assigned using this kind of statement. Fp is equal to F1. This is address. We are putting the address of F1 into Fp, or if we write the ampersand, still we are putting the address of F1 into Fp. But here we are not doing that. When we write the parenthesis, and inside the parenthesis we pass the necessary parameters, necessary arguments, then it becomes a function call. Okay, so it is a function call. We are not assigning the address of F2 to Fp. So because it is a function call, it will call F2, and it will pass the arguments 1 and 2. So this function, it will execute and it will return x plus y, that is 1 plus 2. 3. So it is returning an integer. Okay. So it is returning an integer and we are assigning that integer to a function pointer. Okay. That is why it is giving us this error. You are converting an integer which this function is returning to this thing. What is this thing? This is the prototype of this function. This function has got this function pointer. This function pointer has got two integer parameters. It has got a return type and this is a pointer. Okay, so we are converting the value returned by f2, which is an integer, to a function pointer fp, which is not permissible. That is why this is giving us an error. So always remember, whenever you have to assign the address of a function to a function pointer, then the prototypes of the function pointer and the function should match. That is, their return types and their parameters lists should match, and there should be a parenthesis when you write the name of the function, followed by preceded by an asterisk. And the third thing is that when you assign the address of a function to a function pointer, do not write the parenthesis. It makes it a function call. Okay, always use the name of the function or use the ampersand followed by the name of the function. Okay, so now a question arises that where we use a pointer to a function. So a function can be passed as an argument to another function. We can use it to pass a function as an argument to another function. For example, int abc is a function and it has got some parameters, int a, int b, int c. And we can also have another function as an argument to this function. And suppose here is int, then xyz. This is a pointer to a function. Okay, and this pointer to a function is an argument. We are passing this as an argument to this function abc along with other arguments a, b and c. Okay, so the functions which are used as an argument to another function are sometimes called callback functions. This xyz here is a callback function. Okay, so in order to understand this thing, let us use an example. So let us create a function f1, int f1, and instead of int, let us use void f1. Let us print something here in f1. Okay, and let us write the main function here. Okay, so this is a normal function and I want to use this function as an argument to another function. Okay, so suppose that another function is void f2 and I want to use this as an argument, so I will write the pointer to f1 void inside the parenthesis asterisk and the name of the function pointer fp and then the parameters. Okay, so this is how I am using this function as an argument. Okay, so in the main what will happen, uh, we will call f2 and we will pass f1 as an argument. Okay, so we will not put a parenthesis here. Okay, so because parenthesis will make it a function call. Okay, so f1 means we are passing this f1 address of f1. We can write ampersand f1 or we can just write f1. So this f1 will be passed as an argument, so this address of f1 will be assigned to this function pointer fp. Okay, and here we are receiving fp and we can call fp. So fp, we are calling fp here means this is a pointer, so this pointer is pointing to f1, it means we are indirectly calling f1. Okay, so let us run it. So it is printing in f1. Okay, so this is how we can pass an argument to a function. And the normal scenario, an exemplary scenario in which we pass the functions as an argument are when, suppose when you are doing the sorting. Okay, so sorting of numbers can take place in ascending order or it can take place in descending order. Okay, so you write two functions, suppose one for ascending sorting and suppose this is the skeleton for ascending sorting and another for descending sorting. Okay, so these are the two functions for ascending and descending sorting, and this is the main sorting function, and here you pass the number of elements you want to sort, the array which you want to sort, and here you will write the pointer, you will pass the pointer to the function which you want to use for sorting, and this function will contain the code for the sorting. So in the main function you want to call this sorting. Okay, so you will pass the number of elements in the array, you will pass the array, and here what you will do, you will pass the address of the sorting function, whether you want to use ascending or whether you want to use descending. Okay, so here we are calling sorting, we are passing the number of elements, we are passing the array on which you want to perform the sorting, and here we are passing the function which we want to use. So if we want to sort the number of elements, if we want to sort the elements in ascending order, we will pass the address of ascending function, otherwise we will pass the address of descending function. Okay, so address will be stored here in fp, and here when we call fp, then corresponding ascending or descending function will be used. Everything else in this sorting function will remain same. So you do not need to write two different sorting functions for ascending or descending sorting. You can just use a pointer to the specific ascending or descending sorting. Okay,